Today is Thursday. We're correcting our 8-4 on variables on both sides of the equations. We started here at question 6, and we have half of x is equal to 1.6 plus a quarter of x. We said previously, if you have variables on both sides, the easiest thing to do is to remove it from one side of the equation, and it's usually easiest to remove it from the side that has the least amount to keep your coefficients positive. So by adding a negative quarter x to both sides, I end up with a positive quarter x equals 1.6. Divide by the coefficient, and x will equal, well, how many quarters are there in $1.60? So 1.6 divided by 0.25. There are 6.4 of them. So my answer is a positive 6.4. In the second question, you could remove a sixth of y from both sides. The only problem is here, then you have to subtract the coefficients. A third take away a sixth. Sixth of y. And it gets cumbersome because nobody likes fractions. Everybody hates them. So what we did say to do is to change this. A third of y is easier to be written that way. And a sixth of y is easier to be written that way. And we did agree that if you don't want to work with fractions, the easiest thing to do is look at the denominators of the fractions. 3, 2, and 6. Think of the first common multiple they share. The answer is 6. So if you multiply both sides by 6, you create an equation that is 6 times larger on both sides, but is still equal. Because it's a binomial, we're going to use distributive property. 6 over 1 times y over 3. 6 over 1 times negative 1/2. And 6 over 1 times a sixth of y. That's the work we're going to do. If you didn't cross-reduce the first one, you get 6y over 3, which reduces down to 2y. But if you cross-reduce, you get 2y right away. If you cross-reduce, you get negative 3. And if you cross-reduce, you get y. I'll have to erase because I have no space left. Once you have this, you have a very simple equation. Now, normally I would say subtract y from both sides because it's the least amount, but because you only have one term on the right side, I'm actually going to go against what I said before. I'm going to subtract 2y from both sides. And in doing so, I get negative 3 equals negative y. And if negative 3 equals negative y, I can divide both sides by the coefficient, which is an invisible negative 1. And y equals a positive 3. Okay, that's your solution to a fairly complicated b. It's a good question, though. In C, we have variables on both sides, so I'm going to get rid of it from one side by adding its opposite, which in this case is negative 3.2a. 7.52 is equal to negative 9.4a. Divide both sides by the coefficient. And hopefully 7.52 divided by 9.4 is a fairly simple decimal. And it is, it's 0.8. So therefore, negative 0.8 is equal to a. It's real easy when you work with decimals instead of fractions because it's just the same basic algorithm without having to worry about fraction signs. Now the last one, D, we did say that when you have a mixed fraction coefficient, it's sometimes easier to think of it as an improper fraction coefficient. And if you think of it as an improper fraction coefficient, then it's 5 over 2 times a over 1, which means that 2.5g is the same thing as 5a over 2. If you multiply your numerators, multiply your denominators, you get, which makes sense because 5a divided in half would be 2.5a. So when I rewrite my equation without using the mixed fraction coefficient, I end up with this equation. I only have one fraction. But in this particular case, it is better to double both sides. So if I double both sides, I know I maintain equality. But I'm going to get rid of all the fractions, which in this case is just one of them. 2 times negative g is negative 2g. 2 times half of 5a is 5a. And 2 times negative 3 is negative 6. Now again, the least amount of variable is my negative 2g, but adding 2g to both sides, in this case, is probably not the best move because it would leave me with a 0. So I'm going to subtract 5a from both sides. Counterintuitive. negative 7, or variables g, sorry, negative 7g. Negative 7g equals negative 6. When I divide by the coefficient, your g will equal 6/7, which is your solution, a positive 6/7. Question 7 we didn't have to do. We worked on to question 8. I guess we only wrote down, oh, did I only write down 3 of them? Oh, what a shame. So we have variables on both sides. We have 2.1 of k and 4.3 of k. I'm going to get rid of the 2.1k by adding its opposite. Notice I'm not dividing. I'm just adding its opposite. So that's a neutral, like 2 plus 2k and minus 2k would be a 0. I get 2.6 plus is equal to, sorry, 1.5 plus. When you're combining like terms with different coefficients, you keep the term and subtract the coefficients, or combine the coefficients, I should say. So you get 2.2k. Then you just have a simple question where you'd have a constant. 1.1 is equal to 2.2k. Divide by the coefficient. And k equals a half, or 0.5. 1.1 divided by 2.2 is 0.5. In the second example, I'll change over to red ink here. We have fractional coefficients. Remember, it's easier. A sixth of p is much easier to write like this. A half of p is much easier to write like this. Oh, I forgot an equal sign. That would be good. Plus 2. Once you have that, everyone in the room knows by now that you have to multiply by the common multiple of the denominator. Binomial, going to multiply it by 6. Binomial, going to multiply it by 6. Logan, what do you call it when you multiply a binomial by a monomial? What's that operation called? What's that called? Oh, yes, that's right, distributive property. Perfect. That's excellent. A sixth of p multiplied by 6 is p. Negative 5 multiplied by 6 is negative 30. A half of p multiplied by 6 is 6p over 2, or just 3p, and 2 multiplied by 6 is going to be plus 12. Perfect. Subtract 1p from both sides to get rid of it on one side. You get negative 30 equals 2p plus 12. Subtract 12 from both sides, you get negative 42 equals 2p. Divide both sides by the coefficient, and p will equal negative 21, which is your solution. A sixth of 21 minus 5 is equal to half of 21 plus 2, according to our initial equation. D looks very complicated because we have both fractional coefficients on the left and a mixed fraction coefficient on the right. But I'm going to rewrite it. Remember, 3/5 h is the same thing as 3/5 times h, which is the same thing as 3h over 5, right? That's important to kind of know because I'm going to rewrite it like that. Plus 3h over 5 is equal to, keep in mind, negative 1 2/5 is the same thing as negative 7/5. So negative 7/5 h would be negative 7h over 5 minus 1. Just like that. Mamma mia. Isaiah, what would a smart, intelligent human being do right now? Of course they would, because they're like, dude, I hate fractions. I hate them with a binomial times 5. Look, what do you call it when you multiply a binomial by a monomial? What operation do you have to use there? Distributive property. Perfect. So what we're going to do is we're going to put our distributive property arrows in. 4 times 5 is 20. 3h over 5 times 5 will work out to be just a good 3 old h. Use distributive property over here. Negative 7h over 5, or a fifth of that multiplied by 5, is negative 7h. And negative 1 multiplied by 5 is negative 5. What a beautiful looking, easier equation that is than that original junky looking one. Least amount of h is your negative 7h, so I'm going to add 7h to both sides in hopes that I keep my coefficient positive, which I do. 20 plus 10h is equal to negative 5. Working right along. Now we have a constant, a coefficient, and an equivalent value. Get rid of my constant. 10h equals negative 2d5. Dividez-vous by the coefficient of 10. And don't reach for your calculator. Divided by 10 is a piece of cake. Just move your decimal. H equals negative 2.5. Any questions on D? Question 10 is our next one. And the first question is like our, well, you didn't see it in the video because we did it with paper clips and coins. A paper clip, take away a dime is equal, two of those groups, two paper clips and take away dimes is equivalent to 30 cents take away the value of a paper clip. Oh my God, that's a lot of complicated thing. Here's what I'm going to do. I'm going to expand using distributive property to get 2Q minus 20 cents is equal to 90 cents minus 3Q. Well, that wasn't so bad. Logan would tell you we used distributive property there. Variables on both sides. I have a negative 3Q on one side and a positive 2Q on the other. I'm going to keep my coefficient positive. I like positive coefficients. Get rid of it on that side. I end up with 5Q. Wouldn't it be great if it was 10Q? Then I could say you're welcome. Equals 0.9. It's only 5Q though. It's half a 10Q. Get rid of the constant. 5Q equals 1.1. Divide by the coefficient. Come on, Mr. Mack, you can do this in your head. 0.22. Q equals 0.22. Any questions with that? A? We're good? I guess the only other one we're going to correct is D because I didn't apparently make another one. Just give myself some space there. Obviously, by now, you all understand the easiest thing to do is to multiply both sides by 6, a common multiple of the denominator. So, 6 over 1 multiplied by 2x minus 1 over 2. If you do not cross-reduce, you are going to get 12x minus 6 over 2, which will still work out to be 6x minus 3 when you apply distributive property of division, right? But, if you cross-reduce, you will get 6x minus 3 right away. Wonderful. If you multiply 6 by 2x plus 1 over 3, and you cross-reduce like a civilized human being, you will end up with 4x plus 2. Removing 4x from both sides will result in 2x minus 3 equals 2. Adding 3 to both sides will result in 2x equals 5. And dividing both sides by 2 will result in the solution of x equals 2.5. Which brings us to my favorite math question in the entire grade 9 math book. Question 13 says a jar contains 76 more pennies than nickels. The total value of the pennies equals the total value of the nickels. How many nickels are there? How many nickels are there? So that's our question. So I'm going to put x equals the number of nickels. Remember when you have story, did I spell nickels right? Yes. I always think it's LES for some reason. So the first thing, since I'm looking for how many nickels are, I'm pretty sure x is going to represent that. And then when I look here, I now have enough information to write an algebraic expression to represent the number of pennies, since there's two types of coins in there. And if there's 76 more pennies than nickels, what expression will represent that? Of course, the number of nickels plus an additional 76. So there's our expression for the number of pennies, or the number of pennies. Now here's where it gets complicated. It doesn't say to do this, but the total value of the pennies is the total value of nickels. What is the value of the nickels? If I was to write an algebraic expression for the value of the nickels, since there's X number of nickels and I wanted to figure out what the value is, we would have to multiply the number of nickels by 0.05. If there were 2 nickels, then its value would be 10 cents. If there were 20 nickels, A nickel times 20 is $1. So there'd be $1. So the appropriate algebraic expression is taking the number of nickels and multiplying it by a nickel. And therefore, likewise, the value of the pennies will be taking the number of pennies, which is this much, and multiplying it by 0.01. Because whatever number of pennies there are, that expression represents how many there are, and multiplying it by 0.01 will represent its value. And then we got to go back to this last sentence here. The total value of the pennies equals the total value of the nickels. And that is a significant hint as to what equation you will create. Because the value of the pennies is equal to the value of the nickels, is according to what it says there, the nicks. The value of pens is equal to the value of nicks, which means the value of the pennies is equal to the value of the nickels. And now we have a not so complicated algebraic equation, that we can solve and figure out how many nickels and how many pennies there actually are. So as Logan will tell you, on the left-hand side, we need to utilize, of course we do, we need to utilize distributive property to simplify the value of the pennies, which will be 0.01x plus, don't grab your calculator, because when you multiply a number by 100th, you move the decimal 2 places to the left. So 0.01 times 76 will be 0.76 is equal to 0.05x. I have variables on both sides. I'm going to get rid of this one by subtracting it from both sides. 0 pair. That is going to be equal to, now look, we have gathering of like terms, a positive 0.05x combined with a like term of negative 0. Combine your coefficients. We end up with that. Oh, this is so good. Divide both sides by your coefficient. And x shall equal 76 hundredths divided by 4 hundredths equals 19. But hearken, we are not done yet. Get an idea? X equals 19. Going back up here, if x equals 19, therefore, the number of nickels is 19. The number of pennies would be 19 plus 76, which is 86, 96, 95. There would be 95 pennies, right? The value of the nickels, if there's 19 of them, would be multiplying that by 19, which is just one less than $1. The value of that would be 95 cents. And without doing much math, if I have 95 pennies, I think we all know that 95 pennies is also worth 95 cents. But B does not say what's the value of the penny. It says what's the total value of all the coins in the jar. Well, if there's 95 cents worth of nickels and there's 95 cents worth of pennies, and in that jar there is $1.90. The value of the nickels combined with the value of the pennies.